Most people look for scary things far away. Other galaxies, distant stars, planets thousands of light years out. And sure, those are unsettling. But here's the thing nobody really talks about. Some of the strangest, most unexplained, and genuinely disturbing discoveries in the history of space exploration didn't come from pointing telescopes at the edge of the universe. They came from looking right here, in our own backyard, at things close enough that we've been studying them for decades. And in some cases, the closer we looked, the less we understood. There are 5 things in our own solar system that fall into that category. The last one has been sitting in our data for over 50 years, has been examined by some of the best minds in physics, and still has no agreed explanation. We'll get there. But let's start with the one that most people have heard of and work toward the ones that are significantly harder to shake off. In October 2017, a telescope in Hawaii picked up something moving through our solar system. That alone wasn't unusual. Telescopes pick up moving objects all the time. What was unusual was the shape. Every asteroid and comet ever observed in our solar system is roughly round, or lumpy, or vaguely potato-shaped. The object the telescope found was long, extremely long. Estimates put its length-to-width ratio at around 10:1. Imagine a skyscraper tumbling end over end through space, and you're roughly in the right territory. It was named Oumuamua, a Hawaiian word meaning messenger from afar arriving first. And the more scientists looked at it, the stranger it got. First, the shape was unlike anything seen before. Second, it was moving faster than it should have been. As it left our solar system, Oumuamua accelerated. Not dramatically, but measurably, in a way that comets sometimes do when ice on their surface heats up and vents gas, creating a small thrust effect. The problem was that nobody could find any evidence of that outgassing. No gas trail, no dust, nothing. It was accelerating without an obvious reason. Third, and most quietly unsettling, it came from the direction of the constellation Lyra, traveling in a trajectory that didn't match any known asteroid or comet origin point. It didn't come from the asteroid belt, or the Kuiper belt, or the Oort cloud. It came from somewhere else entirely, passed through our solar system in a clean arc without slowing down, and left. The official consensus is that it was an interstellar object, the first ever observed passing through our solar system, and that its unusual properties probably have natural explanations we haven't fully worked out yet. But one of the theories floated by a Harvard astrophysicist, and not casually dismissed the way fringe theories usually are, was that the shape, the acceleration, and the trajectory were all consistent with a light sail, a thin, flat, manufactured object designed to be pushed by light pressure. Something built. Nobody confirmed that. Nobody ruled it out completely either. Oumuamua left our solar system before anyone could get a closer look, and it is never coming back. That one came and went before we could study it properly. What makes the next one genuinely unsettling is that we have been studying it for a very long time, and we still don't have a satisfying answer. Jupiter's moon, Io, is the most volcanically active body in the entire solar system. It has over 400 active volcanoes on its surface. Some of its volcanic plumes reach 500 kilometers into space. The surface is covered in sulfur and sulfur dioxide, giving it a yellow-orange color that makes it look, depending on who you ask, either like a diseased eye or a pizza that has been left out for geological timescales. None of that is the unsettling part. The volcanoes are explained. Io is caught between Jupiter's enormous gravitational pull and the gravitational tugs of the other Galilean moons, and the resulting tidal flexing heats the interior enough to keep it perpetually molten. That makes sense. What doesn't fully make sense is the radiation environment around Io. Jupiter's magnetic field traps charged particles and accelerates them to enormous energies, creating a radiation belt so intense that the region around Io delivers a radiation dose that would kill an unprotected human in minutes. Any spacecraft we send near Io takes serious damage just from passing through the region. The Galileo probe, which orbited Jupiter for 8 years, had its instruments progressively degraded by the radiation every time it passed close to Io, despite being specifically designed to handle it. But here is the part that moves this from interesting to genuinely strange. Scientists have detected bizarre radio emissions coming from Io's interaction with Jupiter's magnetic field. These emissions are in the frequency range of human radio communications, the kind of frequencies we use to broadcast things. They are natural. We know they are natural, but they are structured enough and consistent enough that when they were first detected in the 1950s, before their source was identified, multiple researchers thought they might be artificial. They're not. not. But every now and then when the geometry is right, you can pick up IO on a shortwave radio receiver on Earth and hear something that sounds, just for a moment, like it's trying to say something. Speaking of things that sound like they're trying to say something, in 1986, Voyager 2 flew past Uranus and returned the most detailed images of the planet and its moons that we had ever seen. Most of the moons were exactly what you'd expect. Cold, dark, geologically dead rocks drifting in the outer solar system. Miranda was not that. Miranda is one of Uranus's smaller moons, only about 470 kilometers across. At that size, a moon should be geologically inactive. Too small to generate internal heat, too small to experience significant tidal forces, just a frozen rock doing nothing in the dark. What Voyager 2 found instead was one of the most geologically chaotic surfaces in the solar system. Miranda has cliffs. Not regular cliffs, Verona Rupes. The largest cliff on Miranda drops approximately 20 kilometers straight down. For context, Mount Everest is about 8.8 kilometers tall. Verona Rupes is more than twice that as a sheer vertical drop. If you stepped off the edge, which, given Miranda's low gravity, would take about 12 minutes to reach the bottom, you would land, technically survive the impact because of the low gravity, and then lie there in a crater at the bottom of the tallest known cliff in the solar system. The terrain around it is just as strange. Ridges, valleys, and grooves run in completely different directions, suggesting multiple episodes of geological activity that shouldn't have been possible for a moon this size. The leading explanation is that Miranda may have been shattered by an ancient impact and then slowly reassembled under its own gravity, with the pieces coming back together in the wrong order. It was broken apart and put back together wrong. That is the most coherent explanation scientists currently have for why Miranda looks the way it does. And every time someone proposes a more detailed model, some part of the terrain doesn't quite fit. Miranda is strange and unexplained. What comes next is strange, unexplained, and actively hostile in a way that most moons are not. Enceladus is one of Saturn's moons, small and icy, and for most of the history of planetary science it was considered one of the less interesting moons in the solar system. Then, in 2005, the Cassini spacecraft flew close enough to take detailed readings, and what it found completely changed the conversation about where life might exist in our solar system. Enceladus has geysers. Not water vapor geysers, full liquid water geysers erupting from cracks near the South Pole and shooting material hundreds of kilometers into space. The water is liquid. On a moon that sits 1.4 billion kilometers from the Sun, at a surface temperature of around negative 200 degrees Celsius, there is liquid water erupting from the surface in columns tall enough to be measured from orbit. The water feeds into Saturn's E-ring, and when Cassini flew through one of the plumes and analyzed what it contained, it found water, ice, salts, silica, and, most importantly, organic compounds, carbon-based molecules, the building blocks of life shooting out of a moon in the outer solar system, into space, from an ocean of liquid water that sits under the ice somewhere between the surface and the rocky core. The reason this is on a list of scary things rather than just extraordinary things is what the organics and the silica together suggest. Silica particles of a specific size form when hot water interacts with rock at high temperatures, a process called hydrothermal activity, which means the ocean under Enceladus's ice isn't just sitting there. It may have hydrothermal vents at the bottom, the same kind of structures on Earth's ocean floor that support entire ecosystems of life completely independent of sunlight. There may be something alive in the ocean under the ice of Enceladus right now. Not definitely, not confirmed, but the conditions are right in a way that scientists did not expect to find this close to home, and every time Cassini's data gets reanalyzed, the case gets slightly stronger rather than weaker. Something might be living in our solar system that we haven't met yet, and it might be close enough that we could reach it within a generation if we decided to go. And then there is the one that has been sitting in our data since 1972, has been examined by physicists for 50 years, and still does not have a fully agreed explanation. In 1972 and 1973, NASA launched Pioneer 10 and Pioneer 11, two spacecraft sent on trajectories that would take them out of the solar system entirely, the first man-made objects ever designed to leave. Scientists tracked both spacecraft carefully as they traveled outward, using precise gravitational models to predict exactly where each one should be at any given time based on the known forces acting on them: the sun's gravity, the gravitational influence of the planets, radiation pressure from sunlight. And both spacecraft drifted, not randomly in the same direction toward the sun, by a tiny but measurable and consistent amount that no known force accounted for. The drift was small, about 8 millionths of a centimeter per second squared, which sounds like nothing. But it was there, it was consistent, it persisted for decades, it happened to both spacecraft independently, and it pointed in the same direction. It became known as the Pioneer anomaly, and for 30 years it was one of the most quietly troubling open questions in physics. The list of proposed explanations included measurement error, unmodeled gravitational effects, heat radiation from the spacecraft's own power systems, dark matter, and modifications to the theory of gravity itself. In 2012, a research team published a detailed analysis concluding that the most likely explanation was thermal recoil, heat radiating unevenly from the spacecraft's plutonium power sources, creating a tiny but consistent push in one direction. Most physicists accepted this as the most probable answer. Most, not all. And the reason it still appears on lists like this one is that the thermal recoil explanation, while the best available, requires a specific set of assumptions about how the heat was distributed across the spacecraft that are difficult to verify 50 years after the fact with hardware that is now over 20 billion kilometers away and no longer transmitting. The anomaly is probably explained, but the word probably is doing a lot of work there. And for 30 years, the best minds in physics looked at two spacecraft drifting in an unexpected direction and could not tell you why. One explanation survived. It's just that in physics, surviving isn't always the same thing as being proven. So that's 5 things of the most scariest things in our universe. If you liked this video, check out this other one we made about the scariest things outside our universe. Also, don't forget to subscribe and turn on bell notifications for more videos like this, and I'll see you guys in the next video.